In this video, I'll be talking about what you'll need to make a solar battery backup system at your home, or if you have an RV, you can make it on. You could make it for your RV as well. And you'll need a couple of things to get this up and running. So the first thing you'll need is something called a deep cycle battery. This is not like a car battery. It's not like a 12-volt car battery, because car batteries are kind of different. Um, they aren't built to be recharged over and over again, because when you have a car battery, you use it basically to start your car up. So the battery has to have a high amount of voltage in order for you to start your car up, right? To jump start your car. And it's not really meant to be like used a lot. So it's just used to start your engine. That's what a car battery is for. And if you use it as a battery to recharge over and over again, then that battery is going to go bad very quickly, because it wasn't designed for being used over and over again like a rechargeable battery. So what happens in your car is that when you start your car, the battery just shuts off. So what happens is your car is running on the gasoline engine, the internal combustion engine. That's helping to generate the electricity for your car. And then the battery just shuts off, I think, after you start the car. So that's how it's used. So for deep cycle battery, you can recharge it anywhere from 1,000 to 3,000 times, depending on the battery. So that's the difference between a deep cycle 12-volt battery and your car battery. They're not the same. So don't try to use a car battery that you buy from some auto parts store, because this is not going to work. You're only going to be able to use it like a couple of times and it's going to go bad. And another thing you'll need is a solar charge controller. This is the unit that you use to hook up everything. Hook up your solar panel or your solar panel arrays, your backup battery, and it has a DC part, a direct current at the end of it. This is for powering lights and stuff. It cannot be used to power your electronics, because electronics require alternating current, not DC, not direct current. So just keep that in mind. In addition to that, you'll need a solar charge controller. No, I already said that. So pure sine wave inverter. So this is what converts your DC power to AC power. So you can hook it up to, let's say, your refrigerator. You could hook it up to your computer, your household devices, your printer, your air conditioner, or whatever. You could use this to hook those devices up, or your television or whatever. And this is a solar panel. You'll need this. You'll need this to recharge the battery. So your solar panel is connected to your solar charge connector, and that routes the energy to your battery, and then the power goes into your battery, and then it goes into your pure sine wave inverter, and you're able to use the power to power your devices. And those are what you need basically, but you'll need other cables and stuff like that. And basically I made this thing right here, this page, and these are the things that you'll need to complete your project. You'll need for me, I want 2 deep cycle batteries. I want 2 solar panels rated at least 200 watts each. I want a sine wave power inverter rated at 2000 watts. And I want 2 battery cables. Solar panel extension cables, one solar connectors, Y branch parallel adapter, solar panel controller, 10 gauge wire tin copper tray cable. And these are how much it would cost for each one. Depending on what your needs are, it's going to cost more or less. So for my estimated project cost, it's going to be about $1,295 to $1,350 for my project. Let's go to the next one. So this is what a solar battery backup system would look like. This is how you would set it up. So let's say this is a 12 volt 300 amp hour battery. So you can set it up in 2 ways. It's called batteries in parallel, or you could set it up in batteries in series. So we're going to be talking about parallel first. So for parallel, you would connect the negative junction of the battery to the negative on another battery. If I have 2 batteries, so negative is black right here, negative to negative, and this would go into the power, the pure sine wave power inverter, and another part would go into the solar panel controller. And the same would be true for the positive as well, which is shown as black, as a red right here. And this is positive. Red cable is connected to the solar panel controller, and it's also connected to the pure sine wave inverter as well, to both basically. This is batteries in series. So when we do batteries in parallel, we have 2 12 volt 300 amp hour batteries. So if we use parallel, then we would get 12 volts, but the amp hours is increased, it's doubled from 300 amp hours to 600 amp hours. So you would get about 7,200 watt hours. So 7,200 watt hours. So let's say you had you were consuming about 350 watts an hour with all your devices. Then you could power it for about 20 hours and 34 minutes with such a setup. But in reality, I'd be using a 100 amp hour battery, so it'd be 12. So I would get, if this was 100 each, I'd get 200 amp hours times 12. So I'd get about 2,400 watt hours. So if I had all my appliances were using 350 watt per hour, I could run it for 6 hours and 51 minutes. If I was using less than that, it would last longer. So batteries in series. So this is when you daisy chain batteries, like when you have 2 batteries. I connect it from this positive lead to this negative lead. So positive to negative, daisy chain it that way, and the negative part of the battery would go into the negative here. Negative part would go into the negative part in the solar panel controller, and it would also go into your pure sine wave inverter. And the positive end would go into your solar panel controller and also your pure sine wave inverter. So that's how it works. So if we do this, if we use batteries in series, we would double the voltage here. So it's 12 volts, 300 amp hour, let's say. So I would get 24 volts at 24 volts at 300 amp hour. So I would get 7,200 watt. I made a mistake here. It's not 3,600. It's 7,200 watt. So we'd get the same, but we would just double the voltage. But that's how it works. We could have them in batteries in series and parallel as well, both. So if we did this, we would need 4 batteries instead of 2 batteries. So in this case, I could have batteries in parallel, like having 2 battery cables connected to each other and 2 positives connected to each other, and they're also in series as well. So I would daisy chain the positive to the negative and positive to the negative to the other battery, and from this part on, this cable, this parallel cable, will connect to the solar panel controller, and it will also connect to the pure sine wave inverter as well from this junction. And the negative, the same thing, solar panel controller and pure sine wave inverter. So that's how it would go. So in this case, we would double the voltage to 24 volts, and we would have double the amp hours as well, 600 amp hours. So in order to calculate wattage, it's wattage equals voltage times current. So 24, current is in amps, the voltage times 600. So we get 14,400 watt hours. So if we were consuming 350, this would last 1.64 days. That's a pretty long time. So now we could have solar panels in parallel and in series as well. So we would connect this in the same way that you connected the batteries as well. So let's say we have 3 solar panels. Each of them is rated at 12 volts at 10 amps. So this will give you about 120 watt hours per solar panel. So we would be able to charge 120 watts per hour with 1 solar panel in this example. So if we wanted to have them in series, we could do that. We could this part goes into the solar panel controller, this part right here, and this part at the end goes into the solar panel controller as well. So we would daisy chain it. If it was negative, it'd be positive, and negative to positive, and then this part goes into the solar panel controller, this part goes in solar panel controller, and that's how you set it up. And if we did this, we would get, since they're 12 volts, and like I said, in series, we would increase the voltage, so it would be 36 volts and 10 amps. So if you want to do this by increasing the voltage, you have to get a solar panel controller which can handle the voltage. So if your solar panel controller can only handle 24 volts, you're not going to be able to install like 3. You could probably install 2 because it could handle 24, but it cannot handle 36. So keep that in mind. So the next one is solar panel in parallel. This is like I said before, if you put them in parallel, you would increase the amp hours for this unit. So it'll be 12 volts. So the way we do this is we connect all the wires for the positives together and then connect it to the solar panel controller. And for all the negatives, we do the same. They do not daisy chain each other. So all the negatives together, all the positives together, and connect to the solar panel controller. So if we did this, we would get about 30 amp hours because we tripled the amp hours here. But the voltage is the same. Voltage did not increase. So we get 360 watts, just like here. 36 volt times 10 amp is 360 watt. So this is how much you could charge in 1 hour, 360 watt per hour. So if the capacity of your battery was, let's say, 2400 watt hours, then it would take you about 6 hours and 40 minutes to charge your battery. So if we could also put them in series and parallel as well, just like in this example. So we would connect the positive to positive here for one of the solar panels, but we would have to have 4 solar panels. We could have 6 if you want, but in this example, I only added 4. So this is, we would put the positives together and connect it to the solar panel array, solar panel controller, all the negatives together, connected to the solar panel controller, and we would daisy chain it here. So this negative to positive. From here, it's negative to positive. And in this example, I would get 24 volts and 20 amps. So that would be a total of 480 watts per hour. And next, what I'm going to show you is the type of connectors you'll need for this project. So these are for the solar panel. It would come with the cables already like this. You would have a negative, which is kind of like a female jack. Positive would be male. You would have the same thing for other solar panels. You would have the female connector and the male connector. So what you would do is, if you want to set it up in parallel, you would just daisy chain the positive to the negative, and then the positive part here goes into your solar charge controller, which is right here. And you would need a cable like this, and this cable is it's a 10 gauge wire tin copper tray cable with a solar connector. So this thing, you see this thing, this is female. You would connect it to the male part, and then this wire would kind of have to be stripped, and you would screw it into this part right here. It goes in this way vertically. Exposed wire goes in here, and then you would screw it in. So you could just buy a cable like this, which is already stripped and exposed, and just screw it into your solar charge connector. And then the positive part would connect to the negative part, which is right here. This is positive, which is denoted by the red cable. This positive part would go into here, into this solar charge controller. You would put it in vertically and then just screw it in. That's it. If you want to do them in parallel, you would need a special cable called this is called a solar connectors, Y branch parallel adapter. So that's what this connector is right here. So you would connect it to here. This would go, then all the positives would go here, positive, into one cable. And then this cable would go, this positive part would go directly into your positive part here in the solar charge controller. And all the negative, you connect the negatives together, negative wire, and we would connect the negative part to here, which you would screw in here, the exposed wire. And another thing, this is for the battery. So if your solar panels was, let's go back to solar panels. No, not the solar panel. So whatever you're able to pull from your solar panel, make sure that your pure sine wave inverter can handle that. Okay, so the higher the amount, so this is 2000 watts, the better. It's going to be able to handle more, the pure sine wave inverter. So basically, we would connect the pure sine wave inverter to the battery, which you see right here. We would use these cables right here. They're just called battery cables. You would connect it here for the positive, which is denoted in red, and you connect it to your battery. And then the negative part is black cable connected to the black part on your battery. And then that would go into your solar charge connector from the battery. Let's say the positive part, the negative part would go into here. And the negative goes into here, the positive goes into here. Just like that. And this would also have to be exposed as well. Or you could just simply cut it, and then you could strip the wire so it's exposed, and you could put it in here and screw it in there. Or you could just buy cables which are which have an exposed extension to it. It's up to you. I'll leave everything in the video descriptions below. And this is not very complicated to do, but you do have to understand the concept behind it, because if you do it wrong, then it's simply not going to work, or cause other problems like shorts and stuff like that, and that's not good. You don't want overcharging either. You want to buy the right power inverter. You want to buy the right type of batteries and stuff like that, and make sure that everything works safely. So if you have any questions, you can leave them in the comment section below. And thanks.